Do you remember the video where I made the houses for Jeremy's house, World 1? This video involves how I'd go about doing the buildings for World 2, Ronnis. However, there are some major changes that I need to make in both worlds, and it also turns out that it's going to affect World 5 as well. Although not very significantly, but still. But what's the problem? Easy. Standards. Everything in my game is based on powers of 2 or the block, in some form or another. Take the buildings. Originally they were 68 coordinate units per floor. Or that's basically how the spacing was. And the logic of that comes from, well, this. This is what 68 coordinate units is in feet. Divide by 75 times 11 will convert coordinate units to feet. And from there you can pretty much go from there. And it turns out 10 feet, slightly less, which is pretty close to what the standards are as far as floor spacing, as far as I'm aware. However, 68 is not a power of 2. What is a power of 2? It's any number where I take 2, raise it to some integer. Like for example, 4 will give me 16. 21, the highest I memorize, is 2,097,152. And of course the lowest I memorize is 128 or negative 7, which is 0.0078125. That's the negative 7. But no fractions are allowed. But either way you get the idea. However, 64 is the closest that I can get to a power of 2 on that. That's 2 to the 6th. Divide 75 times 11 again, and what do you know? It's just a little bit different. Not much different, but it is different. But that's how big it is in feet. And if you want it in meters, for those that are international, that's what it is in meters. So, how do I go about making the buildings? There are a few steps that I need to do, but however, I need to reference my spreadsheet here, and yes, that's a lot of numbers. And very few of these are powers of 2. Let's see. One thing I need you to note, however, is where did I leave off? It looks like here I left off at 23. Notice that these are in reverse order, as in the closest layer is actually drawn first instead of the most distant one. And it's actually just for the looks, because it actually does look more interesting this way. However, I do not need these. What I need instead is to adjust this. So first I need to make this to the image size, and I need to rename it so that I reference the actual scaling. That's what that number is. Scaling? Well, that's basically the size difference, basically, which also affects distance. Well, it's distance technically, but with distance also affects size. So at a scaling of 26, compared to the foreground, it's slightly less than 4% as big. It's tiny. But even then, 26 is still fairly close compared to some of the objects. One look at the furthest mountains in the Sentus Mountains and you'll really think about it twice. I think they're 1792 for the scaling. Yeah, that's huge. That's 256 times 7. Yeah, another power of 2 derivative. However, since I've got this, what I need to do is I need to figure out what the maximum height is, and that's where these come in. This is the minimum, and this is the maximum. So in this case, 94 is the maximum. So what I need to do is I need to set the size of this so that it reflects that 94. And in this case, 94 times 64, and 96. Oh, that's why. 94 times 64. Why did I do that? Then of course I add 16 because there's a cap on top of the building, and that's actually the exact size that I need to use. Okay, another typo. This needs to get scrolled up so that it's cutting off on the top. Okay. And then the next thing I need to do is figure out the nearest multiple of 26. How do you do that? Well, it's actually not the nearest multiple of 26, but the process is actually pretty simple. Notice 1416? 1416 divide 26. Normally you'd think that it would be 54, but that's not what it's going to be, because it's otherwise going to cut off some of the image, and I can't have that happen. Instead, I round it up. So in this case, 55 multiplied by 26, and I get 1430. And I repeat that same process with this one. 6032 divide 26, and it comes out exact, so in that case I can just leave that alone. Convenient anyway, but still. That's the only time you ever leave it exact, is if, of course, if it comes out exact. Because, well, the maximum's 94. That's these numbers here on the side are. That's from this height grid thing here. But what does this look like? Of course, get rid of the height grid, and it looks very repetitive. But it's pretty much all I can really want, actually, for one. And of course, with the height grid, you can see how the spacing on the floors go. 92 here. Yeah, 92. The previous maximum was 32. Now it's going way up to 96. But the randomization only made it up to 95. Yeah, randomization. Randomizers. And speaking of which, I need to adjust those randomizers. How do I do that? Well, I need to keep that. This is what a randomizer looks like. It looks like just, well, a mess, to say the least. However, I need to adjust this thing, because previously on the 23 that it was just finished, it's 31.57, which rounds to 32, but now it's going to 31.24, which rounds to 31. There's a difference there of 1. So I need to adjust this. And one thing I want you to note is look at this. It is very evenly distributed. Every possible color has equal chances, and if you go with logarithmic, it's a flat line. Now that is a real nice way to get random probability. Real nice. However, let's see here. What I need to do is I need to set this to 1, because right now I have it so that 32 is the maximum, but I need to change that. 32 is the maximum. Well, just set this. So yeah, it's at 32 and still 100%. If I go one more, it's going to decrease, so that means it's less. Now, if I bucket fill with subtract mode, and I have the 1 here because I need to subtract only 1, guess what's going to happen to the histogram? It's shifted. And of course it's basically that, and of course if I go with 31, then it's different. That's basically how I control randomization, for one. The color randomizer, that never changes. Never does. So, now that that is otherwise all set and ready to go, of course get this back to normal as well. And let's see, I'm otherwise prepared, so I want to save. Noise maps are very bad when it comes to compression, I'll tell you. So, let's see, 16 buildings, and what was that? Yeah, it's 13 something. And, well, I need to figure out what the actual size is going to be on this for the image. So, let's see, 1430 divide 26, that's 55. Okay, remember that number. 6032 divide 26. 232 times 55 times 4. The 4 is because I'm using 32 bits per pixel. Alpha channel, you know. So, and that's how much each building is going to use. For 16, this is what my image is going to end up using at the most. in bytes. That way I can make sure it fits into the memory slots that I have available. And since it's otherwise good to go, all I need to do is duplicate these. Clean that out. And then I gotta make a lot of copies. Yep, 14. Okay, copy that. This is just so I streamline my process. This does take a little bit of time, but still. Oh, well, that is not really important here anyway, but at least now I can distinguish buildings. This should have been a 2, but oh well. Because then it's going to end up on 15. But when I mass merge everything, I still got 16, so it does check out. So this essentially would be 0. 0 to 15, there's 16 total, so makes perfect sense. So, not an exciting texture, I'll tell you, but it's all I need. Of course, the bottom looks different. That's expected. Now, the first thing I do is I need a randomizer, a different one. This one's for colors, though. For this, all I need to do is pick 2 colors, just pretty much like I did with Jeremy's house, and memorize the first 2. I actually picked 3 and just memorize the first 2. Like this. 213, 230. 213, 230. Okay, and that's what that color turns out to be. Aren't noise maps so much fun? So then I select everything here, and I bucket fill it, and then that one's otherwise done. I move on to the next one, select this, get 3 more colors, or values, 204, 249. 204, 249. And there's that one. And I'll just keep going at this until I'm otherwise done. 255, 195. Pink. How exciting. And now for the last one in the bunch, 244, 224. And I get a nice orange. And that otherwise concludes the random colors phase of the process. Now I gotta do some random heights. And that's where this layer comes in. But of course, save. Since it's now done saving, what I usually do is instead of, well, pretty much the same process, just a little different adjusting basically. So, 84, 37. All I gotta do is reference that. 84, 37. This layer, looks pretty exciting. All I need to do is 84. I just need to go where 84 is. This line right here is the 84. So that means I select this. Okay, and I clear out that row. Now I clear out everything above it. That way I don't have to zoom in and all that other stuff. It's just so much more efficient that way. And of course, 47 I think the other one was. I don't remember what it was already. But I think it was fun. Oh, it's 37. Good thing for that. Let's see. So, 37. Here's the 36. So, that's where I would delete that out. And go up here, clear that all out. And then I repeat the process until these are done. 80 and 62. 80. And 62. Do you get the idea on how the process works for randomizing building heights? Of course, now these need to get moved. And now I just otherwise resume and go for 2 more floors. 41 and 74. Pretty handy setup I have here, huh? And so begin the last two, 66 and 91. 66. And 91. And that otherwise concludes that phase of the process for the buildings. Of course, done with the phase, guess what? Save. So, with all the heights adjusted and the colors set and all that other stuff, yeah, you can see some tall ones. You can see a really, really short one in there. That was actually 31. But one thing you might be wondering, what happens if, well, the maximum was 94, right? What if the randomization, just for example, if I can find one, you're in here somewhere, but what if the randomization gives me something that's outside of the bounds? Like here's a 94. Now if there's a 95 that I can find. Yeah, well, if I got a 95, let's say this was a 95. What I would end up doing is I just pick another one. If that was a 95 too, pick another one. I just keep going until I get it. That's all there is to it. Just look how random it is. You never know what you're going to get next. However, enough with the playing around though. Now I just need to repeatedly scale every one of these so that they're 1/26th the size. And let's see, I think it was 55, but I want to make sure. It's always wise to make sure, and yes, it is 55. So I just scale that to 55. Looks awfully small, doesn't it? There's really not much there. But they're only going to get smaller. Much smaller. Now think of this 1/5 as wide. That's how far these buildings are going to get drawn. So, repeatedly scale. Of course, one thing I like doing is I like bringing out every single one of these, because they're going to need to be visible anyway, so might as well. $55. You can see a color change there. It's because of different heights on buildings. No special thing there. Two more. One more. And there I have it. However, there is one other last step I need to do. Yeah, the last step. And that's to make all of these linked so I can bulk move all these together. Too bad linking and scale layer doesn't work together. So I can't do that in bulk. Come on, thank you. Zoom way in, because I need to be able to see where the boundaries are. Remove that link, join them together. And this part must be included. Just about done. Of course, that being the last one, it doesn't need to be linked. And that's basically the arrangement. One final thing you need to do is merge down, merge down, merge down, and just keep doing this. Isn't streamlining the process so nice? Of course, this being random or shifting and stuff like that kind of throws me off. Of course, that's up at the top, and there you have it. That layer is done. And that otherwise concludes this video. This video was created by Ulillillia. Thank you for watching. And don't forget to save frequently.